Every single ship crossing the Panama Canal relies on a staggering 52 million gallons of pristine freshwater, a design choice that is currently threatening the survival of an entire nation. This immense freshwater consumption keeps global trade moving, but it forces a direct conflict between the flow of international cargo and the daily survival of millions of people. Today, we will uncover why this century-old engineering marvel became its own worst enemy, and why the most obvious solution to this crisis, simply using seawater, is completely impossible. To understand this crisis, we must first look at how this system operates. Within the first few minutes of this story, we will reveal the hidden ecological nightmare that would occur if ocean water ever mixed with Panama's interior lakes, and we will examine how a massive expansion project completed in 2016 attempted to save the canal, only to face a climate reality that no engineer predicted. The Panama Canal is not a flat sea-level trench. Instead, it utilizes an intricate system of locks to elevate massive cargo ships 85 feet, or 26 meters, above sea level. This elevation allows ships to navigate Gatun Lake, a massive man-made freshwater lake that forms a crucial part of the waterway. Gatun Lake was created by damming the Chagres River. This artificial body of water serves as the primary freshwater reservoir for operating the entire lock system. When the canal was designed, engineers chose to utilize a system powered entirely by gravity. The original lock system operates by drawing freshwater from the elevated lakes to fill and empty the lock chambers. This elegant design avoids the need for energy-intensive pumping systems to push water uphill. The water flows naturally from the highest point down to the oceans, carrying ships with it. But this elegant gravity-powered system requires an astonishing volume of water to function. The original lock chambers of the canal are massive. They measure 1,000 feet, or 300 meters, long, 110 feet, or 33 meters, wide, and 40 feet, or 12 meters, deep. To lift a vessel through these giant chambers, a massive amount of water must be displaced. In fact, each transit of a single vessel through the original Panamax locks consumes approximately 52 million US gallons, which is equivalent to 197 million liters of fresh water. Once a ship passes, this water is not saved. It is flushed directly out into the ocean. You might look at this system and ask a very simple question. Why do we not use seawater to fill these chambers instead? The oceans on either side of the canal provide an infinite supply of water, so why rely on limited freshwater? The answer lies in the destructive properties of salt water. Utilizing seawater in the canal's locks would lead to severe corrosion and catastrophic damage to the mechanical components and the entire infrastructure. Salt water is highly corrosive, and over time, it would eat away at the massive steel gates, the valves, and the underwater machinery that keep the canal functional. The maintenance costs and operational shutdowns required to combat this corrosion would make the canal practically unusable. Beyond the mechanical destruction, introducing seawater would trigger an environmental catastrophe. Gatun Lake is a delicate freshwater environment. If seawater were introduced to the lock chambers, it would inevitably contaminate the lake, significantly disrupting the freshwater biodiversity of Gatun Lake and its associated ecosystems. This ecological barrier is vital. Currently, the freshwater lake acts as a natural buffer between two oceans. Introducing saltwater would create a continuous marine highway, potentially facilitating the movement of invasive marine species between the Atlantic and Pacific Oceans. This could permanently alter marine life on both sides of the American continent. This brings us to a shocking reframe of the entire situation. We often view the Panama Canal as a purely commercial asset, a toll road for global shipping. But in reality, the canal is a vital life support system. Beyond its maritime operations, Gatun Lake serves as the main source of drinking water for over 2 million Panamanians. This accounts for roughly half of the entire nation's population. Every time 52 million gallons of freshwater are flushed out of the locks to let a cargo ship pass, The canal is literally draining the drinking water supply of the local population. This creates an intense and direct conflict between global commerce and human survival. This delicate balance is now breaking down. Prolonged droughts, intensified by climate phenomena like El Niño and broader climate change, have significantly reduced water levels in Gatun Lake. The year 2023 was one of the driest periods for Panama since the 1950s. During this crisis, October's rainfall was 43% lower than the historical average. This lack of rain critically impacted the canal's water supply, leaving Gatun Lake dangerously low. As a result, the Panama Canal Authority was forced to implement severe restrictions, reducing both daily ship transits and the maximum draft of the vessels allowed to pass. The economic impact of these restrictions was felt worldwide. During normal operations, the canal accommodates a steady flow of 36 to 38 ships per day. However, during these periods of severe drought, the number of daily transits was drastically reduced, dropping as low as 22 to 24 ships per day. Ships were left waiting for weeks, and global supply chains stalled. To make matters worse, human activity on land is compounding the weather crisis. Deforestation in the Panama Canal watershed has diminished the region's natural capacity to retain water and attract rainfall. Without the forest canopy, the ground cannot hold onto the rain that does fall, further exacerbating the water scarcity issues for both the canal and the surrounding human communities. But what about the modern upgrades designed to save the canal? Let us reevaluate the entire problem. In 2007, Panama embarked on a massive canal expansion project to accommodate larger vessels and address water efficiency. This historic project was completed and began commercial operation on June 26, 2016, introducing the massive Neo-Panamax locks. These new locks were specifically engineered to address the water crisis by incorporating highly advanced water-saving basins. These basins are designed to recycle up to 60% of the water used during each transit, representing a massive technological leap forward. However, even with this advanced recycling technology, the scale of global shipping means the consumption remains staggering. Each transit through these newer Neo-Panamax locks still consumes about 48 million gallons, or 182 million liters, of freshwater. While this is less than the original locks, the sheer size of these Neo-Panamax vessels means the canal's dependency on the watershed is still incredibly high. The expansion allowed larger ships to pass, but it did not free the canal from its absolute reliance on constant rainfall. This reality places the Panama Canal Authority, or the ACP, in an incredibly difficult position. The ACP is constitutionally mandated to administer, operate, conserve, and maintain the canal. Crucially, they are also constitutionally mandated to preserve the water resources of the entire Panama Canal watershed. This means the authority must balance the demands of global maritime shipping companies with the fundamental human right to drinking water for the 2 million citizens who depend on the exact same reservoir. When the rains fail, these two mandates collide, and the ACP is forced to prioritize local survival over global trade. The Panama Canal, a monumental engineering feat of the 20th century designed for sustainability through freshwater lock systems, now faces an ironic 21st century challenge. Its foundational reliance on freshwater has become its Achilles heel. The increasing frequency and severity of droughts, driven by climate change and regional deforestation, reveal a critical tension between global commerce, local ecological integrity, and the fundamental human right to drinking water. This reality is forcing Panama to grapple with the potentially unsustainable nature of its most vital asset. In trying to conquer geography with a gravity-powered freshwater bridge, humanity created a system where global trade remains entirely at the mercy of local rainfall. The canal continues to lift giant ships across the continent, but its future depends entirely on whether it can protect the very water that gives it life. If massive maritime pathways intrigue you, The story of how the world's deepest shipping channels are carved is next. Subscribe to catch it.